All right, the next little piece of our puzzle that we're going to discuss is area, the notion of area. Now, you have probably worked with computing area probably since you're in elementary school, finding areas of rectangles or various polygonal shapes. We know, at least we think we know, the area, how the formula to find the area of a triangle, 1/2 base times height, or the area of the various figures, the area of a circle, pi times the radius squared, and so on and so on and so on. We have all these formulas for area. You've been using them all this time without really understanding, as it turns out, where they come from or why they work, or the reason you did use the area of a circle is pi times the radius squared is because, well, that's what Mrs. Kincaid said, or whoever it was for you. And so you've just used these formulas for area because that's what they were given to be. What we're going to find out is there's a reason why the area formulas are what they are, and that has to do with the calculus. And so, we've now come to this notion of area. We are going to define what we mean when we say area. What is the area of a region? Well, it is this. If f of x is any positive valued function, so f is a function above the x-axis, all right? The function is above the x-axis. Then, if we have, here's a, here's b, and we have some function that falls above the axis. This is y equals f of x. Then the region that lies beneath the curve, the area of the region, beneath the curve, above the x-axis, and between these two vertical lines, that region now that is an irregularly shaped region. It's not a nice circle, it's not a nice it could be any figure. It's not an ellipse, it's not a straight line, it's not a trapezoid, it's just some irregular shaped region. The question is, what is the area of this irregularly shaped region? And the answer is this. The area of that region, when we say the word area means that. That is the area. When we say the word area, we mean that. Anytime in any mathematics course you ever have or will use the term area, you mean that. Area is defined to be this definite integral. The reason you didn't do that way back in 4th or 3rd grade or whatever it was is because you didn't learn the calculus by then. So you were given the final result and asked to use the final result. But now we're getting to the place where we can understand where those results come from and why they are what they are and where those formulas arise. Now here's a specific case. We have a function that's above the axis. We're going to release that restriction here before too long. But for now, we have the region above the axis, right? It's sine of x plus 3. So here's the rough sketch of that graph. And let's suppose our desire is to find the area of that region. That's above the x-axis, between the two vertical lines determined by A and B, and beneath the curve. Well, area, as soon as we say the area, then we know what area is. Area is equal to this definite integral. So the area is the integral from 0 to pi, A to B, 0 to pi. Function, our function is sine of x plus 3 dx, and whatever that works out to be. That's one of the key reasons why when you compute a definite integral, your answer needs to be a number. It turns out one of the interpretations for what you're finding is you're finding surface area. And so in this particular case, now what do we know about this region? Well, just a rough, crude estimate. The length is pi, the height is 1, 2, 3. So that is 3 this way and pi this way, this ought to be length times width. Don't we know this is 3 pi? Well, we don't really know that's 3 pi, but we think we do because we think we remember our stuff from 4th grade. We're going to show why that works here in just a little bit. But assuming that, this rectangle is 3 pi plus a little bit more. 3 pi is approximately 12. This should be a little bit more than 3 pi. Well, let's see if that's what we get. We need to find an antiderivative here. Antiderivative of sine is negative cosine. Antiderivative of 3 is 3x, and that's evaluated from 0 to pi. And then what do we do here? I'm going to steal some space on this side of the board. So that's equal to evaluate at the top minus evaluate at the bottom. Evaluate at the top is negative cosine of pi plus 3 pi. Well, that smells about right. Minus negative, be careful, this minus is here because of the fundamental theorem, this minus is here because of the antiderivative. Negative cosine of 0 plus 3 times 0. So what do we get out of that mess? Let's see, cosine of pi is negative 1, so negative 1, that's 1, plus 3 pi, minus cosine of 0. What's cosine of 0? Cosine of 0 is 1, so that's negative 1, but so we got minus negative 1 plus 0, 1 plus 3 pi plus 1, so that's 2 plus 3 pi. That's a little bit more than 3 pi, which is what we said that should be. So this is, intuitively, it makes sense, but that's the area. It doesn't matter if it makes sense or not. That is the area of that region. Now, why this computation is doing what I'm saying it's doing, I'm going to clarify in our next little video. But from this point on, anytime you're asked to find area, that means you're asked to find a definite integral. Anytime you're asked to find area, that's a definite integral. The word area means definite integral.